Hi, everyone. We're looking at our last topic of our semester review, Chapter 9, Transformations. So we looked at four kinds of transformations. The first was the translation, which meant to slide an object. Oops, sorry, I cannot spell. So we slide an object around, and we were looking at, excuse me, taking your original coordinate, x, y, and to do the translation, we're going to either add or subtract some number to x and then add or subtract some number to the y. And that's supposed to be the letter B, but it does not look very good. There we go. So we add or subtract to the x, add or subtract to the y. Now, there was a special kind of translation that was the vector, and it was a special way to write that rule. So this one said specifically, we don't need the x part or the y part. We can jump straight to the plus or minus, whatever the number is, whatever that movement is. And so that was our way to write a vector rule for translation. The next kind of part that we had was the reflection, which said to flip over a line. And we had 4 lines that we looked at reflecting over. The first one was the x-axis reflection. That said to keep the x, leave it in front. Change the sign of y, leave it at the end. Next, we had y-axis reflection. That said change the sign of x, leave it in front. Keep the sign of y, leave it at the end. Y equals x. Said to keep the y, but move it to the front. Keep the x, move it to the end. So they essentially switch places. Y equals negative x. Said change the sign of y, move that number to the front. Change the sign of x, move that number to the end. So switch their places and change signs. Our third kind of transformation that we dealt with was the rotation, which said to turn. And we looked at specific degrees that we can turn this. Now, by default, we go to the left. But remember, some of these could have the same if we go to the other direction. So a 90 to the left is the same as 270 to the right. And the 90-degree rotation said that we are going to change the y and put that number first, keep the x, and leave it at the end. Now, the 180-degree rotation was the same either way, left or right. That didn't change, but 180-degree rotation said change the x, leave that number in the front, change the y, leave that number at the end. Next was our 270 to the left, counterclockwise, which is the same as a 90 to the right, regular clockwise, and 270 said to keep the y, put that number first, change the sign of the x, put that number last. Now, our other type of transformation we saw was the dilation, which was to change the size of the object. So we had what was called the scale factor, which was a k, and this was supposed to be your new image over the old image. So just some things to remember. If you're dealing with perimeter, our scale factor stays the k. But if we go to area, our scale factor gets squared. All right, let's review some of our vocabulary for just a second with our symmetry. We have what was called the composition of transformations, which is to perform more than one transformation on a figure. So remember, it's like a chain reaction. We had the glide reflection, which was to perform, or was a composition of a translation and a reflection. Then we had what was called rotational symmetry, a transformation that turns a figure onto itself by an angle of 0 to 360. So we had to turn the shape and it lined back up. And how many times could we do that before we get all the way around? Now, with the rotational symmetry, we got order, which was the number of turns that you could get in rotational symmetry, and magnitude was the order, that was a formula, divided by 360 degrees, which is a full turn. So order divided by 360. Now, other kinds of symmetry was our line symmetry, and this said a figure can be mapped onto itself by a reflection over a line, while plane symmetry said a figure can be mapped onto itself by a reflection over a plane. And then our last type of symmetry was axis symmetry, which said a figure can be mapped onto itself by a rotation on a line that is called an axis. So guys, I hope you enjoyed reviewing a little bit of our semester material here. Please don't hesitate to reach out to me if you have any questions. Thanks, guys.